This is the CNC Router Tips Podcast, episode 33. This is the CNC Router Tips Podcast, a show which answers one question from you, the listener, about CNC router tables, CNC software, hardware, web hosting, and business. I'll help you get started in your CNC hobby or business and help you cut through the confusion.
Today's episode is sponsored by TheMakersGuide.com. The Maker's Guide. Useful tools for makers.
Hello, everyone, and welcome to another episode of the CNC Router Tips Podcast. I'm your host, Bill Griggs. I'm so glad you could listen into our podcast today. We're going to be talking about some things that are, I think, very interesting to the newbie, to the absolute beginner coming into CNC, or anyone considering moving up on a CNC machine. But before we get into that, let's just like to mention a few things that are going on that are time sensitive. For instance, if you haven't been to CNCRouterTips.com/contest, you probably don't know that we're giving away a fully licensed copy of Vectric V-Carve Desktop, July 4th, 2016. So that's just around the corner. So if you haven't gone to that webpage and signed up, you're probably not going to have a chance to win. I've been very busy in the shop lately, working on a conversion of a milling machine to CNC control, and I've been documenting that in my blog at themakersguide.com and also on makermasters.com, as well as on my YouTube channel, the Bill Griggs YouTube channel. So if that's something that interests you, you can go and check that out. I would love to have you leave a comment on YouTube, or like the video, or even subscribe. So I know for a lot of CNC router enthusiasts, one of the things that they want to be able to do is to cut aluminum and to cut other metals like steel and brass and things. And you really should consider getting a milling machine if you want to do a lot of that. I know you can do pretty much any metal on a router table with the right rigidity. I know personally of a person who used a Joescnc machine to do some light machining on cast iron, but that is rare, and he is very good at what he does in figuring out speeds and feeds. So in most cases, for something like that, you'd really want a milling machine. But if you want to check that out, it's the Bill Griggs channel on YouTube, and I'd love to hear from you. Now, our question today comes from James Trimble. Now, James has some questions here that I think are very important for people who are just getting started and who are looking to buy their first machine. So take a listen to his question, and we'll get to his answer right after that.
Hi, my name is James Trimble, and my question is regarding the differences between different levels of machine. I'm currently building the mostly printed CNC, which is an extremely low-budget machine, but one that I think presents a lot of learning and hobby opportunities. My question is, what limitations will I encounter in a machine like this, and what limitations and benefits will you find in different levels of machine, ranging from other DIY builds like the Ox or Joescnc, all the way up to the full spectrum of commercial options, such as the Stepcraft, Hytek Tools, or even heavy industrial machines?
Thank you, James. That was a very good question, and I'm a little apprehensive at first about answering it, because I'm going to have to talk in specifics about machines that are made by specific brands. And so I'm just going to tell you what I observe. And there is no slam on any of these machines. I think they are all excellent machines. But you have to realize something. When someone designs a CNC router table, they design it to meet a specific set of purposes, a specific budget, and use specific tools. And you really can't compare each one against the other unless you know what your mission is or what you're trying to accomplish. So all of these machines will do work. Whether they'll do work effectively or the type of work that you're trying to do effectively remains to be seen. So let's get started with just the ones that you actually mentioned in your question. And the first one is the mostly printed CNC. Now, the mostly printed CNC was designed to be 3D printed and to use electrical conduit for most of the axes surface that the bearings would run along. And you can find out information about every machine that I'm going to mention on the resources page at cncroutertips.com/resources. And the company involved with the mostly printed CNC is Vicious One, VICIOUS 1, the number.com. And there'll be a link to that in the resources and in the show notes. But in this case, they gave you all of the part files that you needed to print using a 3D printer, the mounts for your stepper motors and the linear bearing holders and standoffs and that sort of thing, so that you could assemble these pieces together and end up with a router table at the end of that. Now, this is designed to get for guys who already have 3D printers into CNC, and as such, it accomplishes that goal very well. But it makes a few design compromises that might not make it suitable for a production machine over long term. And I've never actually seen one of these in person, so I may be basing my opinion strictly on what I can observe. But what I can observe is that they're using pipe conduit, which is generally aluminum, I believe, and they're using roller skate bearings, which are held by this 3D printed carriages. So the roller skate bearing edge rides along these pipe conduits, and that allows it to, get its linear motion. Well, one of the things that I noticed in the photographs on Thingiverse and on other sites that are showing pictures of this is that those rails have wear marks on them, and that's because the outside of the bearings are harder than the rails that they're riding on. So that's not a problem short term, but it is a problem long term, because as the machine gets used more and more, the surfaces will wear, and they will wear unevenly because you won't always cut in the same areas every time. And so things will wear unevenly. But pipe conduit is very cheap. You could just rotate it and get a new surface exposed and continue working. So you could do that for quite a while. So in that respect, it's probably not a big issue. It's just something that you should be aware of as routine maintenance. And most of these machines do require routine maintenance. So if you're not prepared to do that, then you're going to be in for a world of disappointment in any of these machines, because you need to take care of them and make sure that they're running smoothly. So the other factor that plays in, and you're going to hear me repeating this in every machine when we discuss it, is how rigid is the machine. In other words, how much force can be applied with the machine before it flexes in some way. And the reason that's important is anytime you have something that deforms or flexes, you are changing the trajectory of your tool, and that will change the finished product. And so you won't, necessarily get the best finish, or things won't be exactly the right shape. Now, there are plastics that are very strong and have characteristics very similar to aluminum or steel. And so I'm not going to say that because this is made out of ABS plastic or PLA plastic that it won't stand up to the stresses, because I really don't know. And that would take me to do, some kind of analysis to find out what the exact strengths are. But I assume, since many people have already built this machine, that it is probably a workable solution. So you'll be able to make whatever people have already shown that they could make. It's using a trim router for in the videos that I saw from DeWalt, which is not a very powerful router, but it is one that I've used before, and it will give you pretty good results. It uses a belt drive on this machine, and so, there will be some backlash in that system, but, it's plenty manageable. Lots of machines are using belt drives now instead of rack and pinion or lead screw or ball screw. So I don't think that's a dissuading factor. What will dissuade you eventually is the speed, because I've watched the videos of these, and they're not capable of going very fast as far as the feed rate is concerned. They're going to be a conservative beginner desktop machine, which is what it's designed for. And so in that respect, I think it is a well-done piece of engineering. So let's move in and compare it to something a little more sturdy, and that would be the OpenBuild Ox. The OpenBuild Ox is a freely available set of plans to build your own CNC router table using parts which are available through the OpenBuild's parts store, and it's openbuildspartsstore.com. And there'll be a link to that in the resources and in the show notes. Now, one of the things about this is the Ox uses what is known as V-slot linear rail, which is the result of a Kickstarter project where a guy decided that he wanted to create a unique aluminum extrusion that would combine several functions. And one of those functions was allow you to use V-groove wheels, which are very common in CNC machine, right along with this aluminum extrusion. And so he designed his own V-groove wheel, as well as using those commercially available ones. The one he designed is out of a plastic, which I believe is Delrin, but I'm not 100% sure. And rather than having a linear rail or guide system, which can cost a lot of money, there were V-slots milled or extruded, actually, right into these rails, and the wheels ride along those, and that provides you with your linear motion. And they offer these in a variety of sizes from 20 millimeter by 20 millimeter on up to 20 by 80. And just to give you a perspective for those of us here in the U.S. who aren't really familiar with millimeters, 20 millimeters is about 3/4 of an inch, or about as thick as a standard sheet of plywood. Okay. And 80 millimeters is just a little over 3 inches. So if you imagined a strip of plywood that was 3 inches wide, 3/4 inch plywood like you would put on your roof, you'd have an idea of how big this aluminum extrusion is. So it's in my opinion, kind of on the thin side at 3/4 of an inch, but it's still pretty beefy as far as most of these little home-built desktop size machines are concerned. So if you're looking at this from the perspective of wear, like we were looking at the mostly printed CNC, this doesn't really have that problem because you're using plastic wheels on an aluminum V extrusion. So the wear and tear is not going to happen on that. And, it provides a fairly consistent rolling surface for these things. One of the other things that comes with, building something like the Ox is it's using plates that serve multiple functions. And so you can buy these parts that have, many holes drilled in them so that you can use them in a variety of different locations during the course of this build. So these are generalist parts and not specialized parts. So they're not, limited to doing one thing. And that can be good and that can be bad. Personally, I think it's wonderful that, somebody can go and just grab a bunch of these different parts and put together pretty much whatever machine that they want. And for that reason, I think that this is just like the mostly printed CNC, a good solution for people who are looking for something a little bit more sturdier than the mostly printed machine. One area where the Ox will not compare with a commercial machine is in the CNC electronics that are used. And just briefly going through their website, it looks like they are using chili pepper, which is a very popular open source control software. But for the electronics, they are using a board which is a CNC Controller Pro board version 2, which is a purpose-built machine that will do a lot of things, but it's Gerbil based, or I believe that's how they pronounce it, GRBL. So it's 100% compatible with that, and that just means that it uses a specific set of commands to drive it. So you would not, for instance, be able to run this driver with Mach 3 or with some of the other drive software that are out there for the larger things, because this is using a microprocessor very similar to an Arduino or a Raspberry Pi to get its signals. So as far as an upgrade path with this electronics, these electronics wouldn't generally be used to run a larger machine later on, because they simply wouldn't handle the amp draw. These are like 2.5 amps peak for the stepper drivers, and most of the steppers that I'm aware of will draw a lot more current than that. And it also has voltage limits. It's limited to 24 volts, and the majority of the larger machines would operate in the 48 to 60 or 70 volt range. So that's one disadvantage. But one great advantage that the CNC Pro controller has is that it doesn't cost a whole lot. It's $129 for the controller, and you just have to add a power supply and the stepper motors, and you're in business. So it's a very inexpensive way to get your machine moving. Also, there's a very large community of builders for the Ox build, OpenBuild, for the Ox CNC router OpenBuild puts out. And that's also a good thing when you need help or assurance or you're just confused with something. Having a community out there to go to is always a great thing. So there's a lot of people using the Ox build as an entry-level machine. And I'll do my best to reach out to somebody in that OpenBuild community to see if we can get them on the podcast. That would be nice to talk to them about what they're up to and what they're trying to achieve, and see in what way we can help. Okay, James, the next machine that you mentioned was the Joescnc, and Joe was on our show just a while ago in episode 24. So if you'd like to hear about him and his machines, you could check out CNCRouterTips.com/24, and that will take you to that episode. Now, the Joescnc is a set of plans to build your own 4-foot by 4-foot or larger CNC router. And this is where the machine that I currently have, it is a Joescnc variant. And one of the things that differentiates the Joescnc machines from the types of machines that we used before is the size of the aluminum extrusion that is used in their construction. Now, each of the two machines that we mentioned before used some sort of rail to hold up the system and to let the bearings ride along. And in both cases, in the case of the OpenBuild Ox, it used a special aluminum extrusion that was about 3/4 of an inch by 3 inches in size. And the Joescnc uses an extrusion that's made by 8020. I believe that's 8020.net. I'll have a link to that in the show notes. But the size of this extrusion is roughly the size of a 2x4. It is 2 inches wide by 4 inches high. And so there's a lot more metal there, and it's a much more rigid system. It's also much more expensive than the V-groove extrusion that the OpenBuild Ox uses. So just the basic size of that, increased size of that aluminum extrusion puts this into a different category. So it's unfair to compare the two to each other. And Joe's latest design, the Evolution, or the Evo for short, even goes a step further in that it uses for the X carriage a 3-inch by 6-inch aluminum extrusion, which is really beefy and extremely heavy. So this puts the Joescnc machines very close to a commercial machine, depending on what other features you use. Because with the Joescnc, you can use unistrut for the base, you can use a wooden base made out of 2x4s, or you can use a welded steel base. And the majority of the new machines being built use the welded steel base. So again, the two machines that we mentioned before never really take into account the base. They're essentially using those aluminum extrusions as part of the base, and you build a table under them, or you put them on a workbench or whatever. But the Joescnc stuff is designed to be standalone, in the room, and it's going to take up a lot of floor space in your shop. If you're building a 4-foot by 4-foot machine, it's actually going to be 6 foot wide by 6 foot long in order to have a 4-foot cutting area. That's just part of the way it works out. So the other thing with the Joe's CNC machines is they're not necessarily one machine, but it was a series of machines that evolved over time, and that's why his newest one is called the Evolution, because it has been a steady evolution of the design since when it first came out in 2009. So the originals had MDF carriages on the side, and used the smaller extrusion that I discussed earlier, and they used unistrut, which is something that commercial electricians use to hang wires and pipes and things, and plumbers also use it to mount things in buildings. And it's very nice. It's like a giant erector set of parts, but it's not generally terribly stable because it is bolted together instead of welded. If it were welded, all bets are off. It's pretty strong. But having it bolt together allows some flexibility that, frankly, I'd like to get rid of. My base is still made out of unistrut, and I'm just too lazy to weld one together. But, that is one thing to consider. And that, without a welded base, I don't consider this a commercial machine. But with a welded base or a wooden base, this machine can keep up with any of the commercial machines out there. As far in that size range. Now, other things to consider with a Joescnc machine is that it uses a full-size router, or it can use a 2.2 kilowatt spindle, just like many of the other machines now they're coming in from China with that size spindles. And a spindle that size will allow you to do things like cut a sheet of plywood in one pass. So, very powerful router compared to the two that we've discussed before, because it's designed for that purpose, to be a bigger, better router. And if you need that, then this might be a good solution for you. You can put one together for between $3,000 and $5,000 and have a machine that's probably very close or comparable with $10,000 commercially available machine. The difference is it takes you time to source out your parts and build them into the machine, and that's what you're trading your time for money. One other thing that you get when you build a machine like the Joescnc is the ability to customize the machine to your specific needs. And that is something that is very powerful and very handy, because if you don't need a feature, you can eliminate it. If you want to add a feature, you can do that. Your pretty much only limited by your imagination and how deep your pocket is. So, the Joescnc does share that kind of feature with the OpenBuild Ox, because if you want to customize an Ox, you can do the same. So that is one reason why a lot of people will build the Joescnc or similar machines from plans, because they get the final say in what goes into it. Now, as far as the linear motion system goes on the Joescnc, it uses hardened V-wheels, bearings like from Bishop Weiscarver or other similar places. It's a commercially available bearing that's shaped like a W on the bottom, or like little V's on each portion of the wheel. And they're designed to ride on hardened rails, or in the case of the Joescnc, angle iron. Now, many people have used angle iron. Many people have used the hardened rails. Again, it's one of those things where you get to choose what it is that you want to use. Some people have eliminated the V-wheels altogether and the V-rails and gone with linear bearings, commercially available linear bearings instead. Because of the nature of the Joe's plans, you can slide those on instead and, just pay more. And now you have a more commercial level of machine again. So there's just so many different ways to look at that. And there really is no comparison between hardened V wheels and Delrin wheels. They're just night and day. They're two different applications, and you really shouldn't compare them unless you're in the same size machine. They're both good solutions, but in my opinion, for the money, the hardened wheels are better. I'll have a link to the Joescnc website, which is joescnc.com, in the show notes and also on the resources page, along with a link to one or two of my YouTube videos of my machine. So if you want to take a peek and see what it is we're talking about, you can do that. And that's on the Bill Griggs YouTube channel. So let's move on to the next machine.
Today's episode is sponsored by The Maker's Guide, creator of the Triple Edge Finder. Get the edge you need, save time and frustration on your CNC project, and make setup a snap. Save time and material. Set up your workpiece on your CNC router table faster than ever. Accurately set your Z-axis height first time, every time. Automatically locate the corner or edge of a workpiece. Reset your starting point in the middle of a program. Quality crafted right here in the USA on US-made CNC machines. Get the edge you need today. Go to www.themakersguide.com/edge. The Maker's Guide. Useful tools for makers.
Now, James, you mentioned the Stepcraft machine, and also the Hytek Tools machine. And those two machines are completely different as far as their intended use and their purpose. The Stepcraft is a much smaller desktop-sized machine, and it is very ruggedly built. If I were looking at it side by side with the Ox build, I think I might give the edge to the Stepcraft, but it's designed as a box of parts that you assemble into the completed machine versus the OpenBuild, which is designed as a bunch of parts which you can build into whatever your desire or skill will allow. So it's a different mindset. It's a different philosophy in the two. The Stepcraft is a very high quality machine. It is driven by a lead screw instead of a belt drive. And it uses brass bearing wheels, or brass V wheels, if you will. And they're not actually V-shaped. They're sort of V with a arc in the middle of them, specially designed to fit the custom aluminum extrusion, which is used on these machines. And that extrusion is very, very heavy duty compared to some of the other stuff. In fact, it really kind of surprised me when I began my build of a Stepcraft machine that it was quite as hefty as it was. I had completely discounted it and thinking that it was a lightweight machine, and it really is more of a medium weight machine. The Stepcraft machine comes with its own controller system, which is still fairly low on the amperage carrying capabilities. That puts it in about the same category as the OpenBuild as far as the amount of amps that you can use for those motors and the voltage. But the controller is a little more towards the sign towards being a standalone controller than it is just a microcontroller that has been adapted as a controller. It uses either Mach 3 or CNC for the control driver, and that gives you some flexibility, so you can basically outfit it whichever way you want. It has a USB interface for the control system, which is very similar to what the Ox build would have. So, when you compare the two that way, it's very similar. You just plug it into any USB port on your computer and off you go. So from that standpoint, it would work with a modern machine. You wouldn't have to go out and try and find an older PC to try and use a parallel port, because it doesn't really have to be that way. Also, the Stepcraft machine would cost a little bit more than the OpenBuild Ox, but the difference is you get a box of the parts that assemble the completed machine. It's a kit with everything in it. So, you're not going out and trying to buy things, and you're not trying to choose different things, although they have lots of accessories. It's a pretty rugged little machine. So that kind of describes what the Stepcraft is. Now, the Hytek Tools machines that are coming in are machines that are actually brought in and made specially for Hytek Tools in China. And what you get when you get one of those machines, aside from the ball screws to drive things around, and the heavy duty router and the welded frame, very similar to the kinds of things that you would get in the Joescnc that was built the right way. What you're buying is the folks at that company picking up the machine, driving it to your home, your workshop, wherever you want it, installing it, getting it set up to run, and then spending a couple of days teaching you the basics of how to run and operate your machine. And so what you're buying is customer service and a machine with a set number of parts, that they'll already know what they are and, customized to your needs. And that's what you would get with something like a Hytek Tools machine that we discussed back in episode 27 with Melissa Jones. So, that is basically what you're getting with those type machines. Now, as far as commercial machines, some of the larger commercial machines that are built by companies like Cam Master and Onsrud and places like that, those are a totally different beast. And when I say beast, I'm referring to the way these things are built. I worked on a machine that was built by Onsrud, which is a company somewhere in the southeast. And this machine, for instance, had a base that had 12-inch by 12-inch steel tubing for the bed, interconnected with a couple of other welded pieces. And on top of that, it had linear guide rails that were the entire length of the bed, 4 foot and 8 foot. It had a belt drive system which drove large ball screws. It had an automatic tool changer. It had a vacuum bed built into the machine that split into two, so you could run one 4-foot panel on one side and another 4-foot panel on the other. It was quite large and took up the majority of the area in this workshop, and it required a very large compressor and its own vacuum pump and a rotary phase converter to provide 3-phase power to it. So that's a totally different beast than what we're talking about up till this point. A machine like that will cost in the neighborhood of $50,000 to $300,000, depending on what you choose. They will do amazing work. They're designed to work 24 hours a day, 3 shifts every week. Those are robust industrial-sized machines, and if you can find one used that's in good shape, that you can find someone who knows about it, you can get a lot of machine for very little money. But if you're buying them new, you're going to be taking out a mortgage. So, that's the difference between a commercial machine and what most of us use, which are light-duty machines or hobby machines. So I hope, James, that answered your question. I'm sure I could talk quite a bit longer about what the differences are in each of them, and I hope that each of the companies that I covered could take my honest opinion on what my observations are on their products based on what I've observed. I'm not the final source on any of this, so you go out and make your own decisions, but at least now you have some ideas of the things to look at and how to evaluate one machine against another. And because your question was answered on this podcast, we'll be sending you a free gift. Now, as we mentioned at the top of the show, we are having a giveaway. And we're giving away a licensed copy of VCarve Desktop from Vectric Software. All that's required from you to win is to go to CNCRouterTips.com/contest and fill out the entry form. There's no purchase necessary, void where prohibited by law, all that other good stuff. In fact, the contest rules are right there for you to read. But you've got to be 18 years old or older to enter. And you have to be in the continental United States or Hawaii or Alaska. They count too, in order to win. For those of you that don't know, VCarve Desktop is amazing software, and it's really good piece of software that'll get you going, creating all sorts of carvings from profile cuts to fluting to pocket cuts and VCarve cuts. And it's designed specifically for those who have a desktop-sized CNC, although it can be used with larger machines. So if you'd like to win this software, which is valued at over $350, so I know somebody's going to love to win this prize. So don't forget to enter the giveaway of VCarve Desktop software by going to CNCRouterTips.com/contest. The deadline for that contest is July 4th, and if you're not in it, you can't win it. I often mention many different types of software during the episodes, and hardware and cutters, and it can get a little confusing. So what I did was I put together a page on my website, CNCRouterTips.com/resources. And on that page, I list all sorts of resources there, from books to tools to software, all the things that I use that make my CNC experience better and easier. And I hope you'll check it out. So again, it's CNCRouterTips.com/resources. Now, if you'd like to have your question featured on the air, here's how. Need help? Ask me about your CNC router question on my podcast, the CNC Router Tips Podcast. I'll be glad to help or try and get you the help you need. I want this podcast to be a fun and personal experience for everyone and helpful. So let's keep it real and ask sensible questions. Please use common sense and show courtesy to everyone. That way everybody wins. Here are some guidelines to ensure that your question is qualified to be featured on the show. Please keep your questions under 1 minute in length. If it goes a little over that, that's fine, but don't ramble. If you have a website and URL, you're allowed to share it, but only once during the recording. Spammy or disrespectful or deeply private questions will not be considered for the podcast. If you need to ask more than one question, just make each question a separate voicemail. Thanks again, everyone, for tuning in and listening to the CNC Router Tips podcast. If you'd like to join our free mailing list, you can go to CNCRouterTips.com, and there's a link right there on the top of the page which tells you how to do that. Thank you so much, and have a great day.